Your API might be exposing more than you think. From data leaks to unauthorized access, we're covering the top security practices that every developer needs to know to keep REST APIs secure. Let's dive into them now. Securing a REST API starts with limiting who has access to the API and what they can do with that access. That's where authentication and authorization come in. You should use strong authentication methods like OAuth 2.0 and implement role-based access controls, or RBAC, to limit user and system permissions in your API. And speaking of OAuth, you'll likely be using tokens to manage access to your API. Make sure to use strong authentication tokens and manage them securely. Tokens should have expiration times and use secure storage practices like cookies for better security. All right, we all should pretty much know this by now, but just in case you don't, you should use HTTPS for data transmission. HTTPS encrypts network communication, thus preventing attackers from easily intercepting sensitive information. Speaking of that, let's jump into a quick example in Python of how to set up HTTPS in a project. In this quick example, we're using Flask as the framework for our API in Python. And with that, we imported the SSL-FI package so that we can set up SSL HTTPS to be used within this API. And that's a quick example of setting up HTTPS in a Python application. Next up, you want to enforce input validation and sanitization. You want to validate all user inputs are what you expect them to be to prevent attacks like SQL injection and cross-site scripting, or XSS. This keeps your API safe from malicious inputs. Let's take a quick look at an example of how you can go about doing that in JavaScript. All right, first up, we're going to take a look at validation. Validation involves making sure that the data you're receiving from users are up to par with what you expect them to be. So in this case, I'm expecting the user to provide an age as part of the data that they're sending to me, and that should be a number. And if it's not a number, then I need to know that and validate that. And that's what we're doing here inside of this function. Next up, we have sanitizing input, and that involves removing malicious data based on the context that that data is going to be used within. So in this case, we're expecting to use this data in HTML, and therefore we don't want to allow angle brackets like this, whether it's the less than or greater than, and other characters similar to that could be used to circumvent and break out of the scope of HTML and start executing some JavaScript code in the browser. So what we do here is we replace those characters with empty strings so that we sanitize, remove that malicious character and data out of the data we receive from users. All right, so with an API exposed to the internet, you'll likely run into malicious actors trying to overload your API with requests. For this, you'll want to implement rate limiting and throttling to control the number of requests a user can make in a given period of time. This reduces the risk of what's called DDoS, or distributed denial of service attacks. After that, you should adopt standard security HTTP headers in your API responses. Some examples of them are a content security policy, or CSP, and cross-origin resource sharing, or CORS. These headers help to control which origins can access your API, reducing the risk of unauthorized access and malicious attacks. Let's now take a quick look at a short example in TypeScript for a Node.js API on how we set up these HTTP headers. All right, in this example, it's a Node.js application using TypeScript, and it's using Express as the web framework to set up the API. And then I'm relying on these two packages to help with the security headers, Helmet and CORS. Helmet is helpful for setting up different security headers like content security policy that I said before, among other things. And then CORS is what it says on the tin, cross-origin resource sharing. It sets that up too. Now I'm just using the default configuration for those, but if you'd like, you can go check out the package's configuration options to sort those out the way you need for your application. But this is a quick example on how easy it is to get started with those security headers in a Node application. Now, you will undoubtedly run into issues, bugs, and odd behavior over time with your API. To keep track of everything, you need to enable API logging and monitoring. Monitoring is going to help you detect unusual patterns like repeated failed logins, which can indicate potential security threats. Last but not least is you need to make sure you use secure dependencies. You likely rely on several dependencies to implement all the features needed in your API. As a result, that's more code that could contain vulnerabilities that you're unaware of. A real-world example of this happening was with the infamous Equifax data breach back in 2017. This was found to be a result of depending on a vulnerable version of the Apache Struts package in their application. So to keep on top of these risks, you can use Snyk to scan and monitor your open source dependencies so that you'll be alerted to any security issues found in them. For more information on securing your REST API, you can check out the full blog post that's linked in the description below. That does it for this video. If you got value out of it, be sure to like it down below and share it with someone who could put it to use. And if you made it this far, subscribe to the channel so you don't miss out on upcoming videos. Thanks for watching and happy, safe coding, everyone.